Hey, welcome back, squad. Happy Tuesday. We are going to put fractions in the simplest form using our greatest common factor. But first, we're going to go over the three problems of the PDN before we look at some notes and do some examples together. Looking at how our page should look, we're first rounding the same number as yesterday, 752,681 to the nearest thousands. So I'm going to circle up that 2-digit in the thousands place. I'm going to draw an arrow next door to that 6. I know that since 6 is greater than 5, I will be rounding up. I'm going to put a 1 there just as a reminder. And then I'm going to keep every digit before the circle digit, the 7 and the 5 and the 100,000s and 10,000s the same. I'm going to add 1 to my digit 2 to make 3,000s, and everything after the hundreds, tens, and ones become a 0. Same thing for looking at number 2. I'm now rounding to the nearest 10,000s, which is that 5-digit, and I'm going to draw an arrow to that 2-digit and ask myself, is 2 greater than or less than 5? Since 2 is less than 5, I round down, which means this circle digit stays the same. 7 does not change. 5 does not change because I'm rounding down, and the thousands, hundreds, tens, and ones all become zeros. 0, 0, 0, 0. Which means 752,681 when rounded to the nearest 10,000s is 750,000. I'm now going to try to simplify 50 100ths to the smallest possible fraction. I know I can divide first by 10 because I have a 0 in my ones place in my numerator 50 and a 0 in my ones place in my denominator 100. So I'm going to divide by 10 over 10. I roll my 10s until I get to 50, 10, 20, 30, 40, 50. It's 5 times, which means 50 divided by 10 equals 5. I do that same thing until I get to 100. 5, 10, 15, 20, excuse me, I'm doing 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, which is 10. Now I know I can't divide by 10s anymore because there isn't a 0 in my numerator's ones place, there's a 5. But I can divide by 5 now because there's a 5 in the ones place in my numerator and a 0 in the ones place in my denominator. So I'm going to divide this fraction by 5 over 5. And I know right now 5 divided by 5 equals 1. I roll my 5s one time to get to 5. And 10 divided by 5 equals 2. Just like yesterday, 50 100ths, just like 30 60ths, 50 100ths simplifies all the way down to 1/2. Today we're going to talk about simplest form again, just like we just did in that PDN. When we reduce a fraction to its simplest form, we're creating it in the smallest possible terms, which means we cannot divide it again. We've been using our divisibility rules, which as you saw over here, made us have to do 2 different division problems. Right? We had to divide by 10 over 10 and by 5 over 5. We're going to work today using our greatest common factor, which will make it a little bit easier for us, and use our factor pairs that we did yesterday to find the simplest form. The greatest common factor is the largest factor of 2 numbers. Here's how we put a number in the simplest form using the greatest common factor. First, we list all the factor pairs for our numerator and our denominator. Then we find the greatest common factor, or the largest number that's a factor of both our numerator and our denominator. Then we divide the fraction's numerator and denominator by that number, the GCF, and that will be 1 whole, and we'll have simplified our fraction then. When you find your factor pairs, you're going to see we've done all the work already once we find those factor pairs. Our first example is 24 over 30. First step to find our fraction into simplest form using our greatest common factor is we're going to list the factor pairs for both 24 and 30. I'll start with 24, and I'm going to ask myself what numbers can be multiplied together to equal 24. The first one is 1 times 24 always. I know also that 24 can be divided by 2 since there is a 4 in the ones place, which makes it an even number. And I know if I rolled my 2s 12 times, I would get 24. So 12 times 2 also equals 24. I know I can't divide 24 by 5 or by 10 because there is no There is no 0 or 5 in the ones place. There's a 4 in the ones place. So I'm going to ask myself now, can I divide 24 by 3? Well, 2 plus 4 equals 6. And I know I can roll my 3s, 3, 6, and land on 6. So 24 is divisible by 3. So I can roll my 3s until a certain number and get 24. I'm going to roll my 3s right now until I get to 24. 3, 6, 9, 12, 15, 18. Drop it like it's hot. Drop it like it's hot. 21, 24. That's 5, 6, 7, 8 times. 3 times 8 equals 24. Also, this is just something that I know from knowing multiplication, but you could look at your multiplication chart or your rolling numbers packet. 4 times 6 also equals 24. So I have these 4 factor pairs for 24. Now I'm going to find some factor pairs for 30. First, I know 1 times 30 equals 30. Since 30 is divisible by 5 and 10, I can put those down since there's a 0 in the ones place in 30. So I'm going to first do 5, and I'm going to roll my 5s until I get to 30. 5, 10, 15, 20, 25, 30. That was 6 times. I'm also now going to know that it's going to be multiplied by 10. I'm going to roll my 10s until I get to 30, 10, 20, 30. That was 3 times. 10 times 30. Sorry, 10 times 3 equals 30. And I also know that 30 can be divisible by 2 because there is a 0 in the ones place. Yes, a 0 in the ones place, so it's an even number. Now I'm going to roll my 2s until I get to 30 to see what 2 times what equals 30. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 5, 10, 15. 2 times 15 equals 30. I've now found my factor pairs for both 24 and for 30. So now I need to find the greatest common factor, or the largest number that is both on my 24 side, that's a factor of 24, and a factor of 30. So I'll start with the largest number I see, 30. Is 30 on my 24 side? No. So I'm going to cross that one out. It can't be the greatest common factor. Next biggest number is 24. Is 24 on the 30 side? No. Next biggest number is 15. Is 15 on this side? No. I'm going to go to the next biggest number is 12. I don't see a 12 on my 30 side. Next biggest number is 10. I don't see a 10 on this 24 side. Next biggest number is 8. I see an 8 here. Next biggest number is 6. Oh, I see a 6 on both as a factor of 30 and a factor of 24. So my greatest common factor, or the largest number that is a factor of both 24 and 30, is 6. So now I can reduce this fraction by 6 over 6. I already know how many times I have to roll my 6s to get to 24 because I've written it out as my factor pair, which is like a little bit of a cheat. I know that 24 divided by 6 equals 4 because 4 times 6 equals 24. Similarly, I can also find what 30 divided by 6 equals because I know 6 times 5 equals 30. So 30 divided by 6 equals 5. And I have reduced my fraction, 24 30ths, to 4 fifths. Now that I've solved my first example, I'm going to go over the number 2, which is 16 20ths. Again, the first thing I do when I'm simplifying a fraction using the greatest common factor is I'm going to find my factor pairs for both my numerator and my denominator. My numerator is 16. I know that 1 times 16 equals 16. I also know that 16 is divisible by 2. And I'm going to roll my 2s until I figure out what times 2 equals 16. 2, 4, 6, 8, 10, 12, 14, 16, 5, 6, 7, 8. 2 times 8 equals 16. I also know that 4 times 4 equals 16. Those are my factor pairs, those 3, 1 times 16, 2 times 8, and 4 times 4 for 16. Now I'm going to do the same thing for 20. I know that 1 times 20 equals 20. I also know that 20 is divisible by 10. and by 5, which means I can roll both 5 and 10 and get to 20. 10, 20, it takes me 2 times to roll my 10s to get to 20, so 2 times 10 equals 10 times 2 equals 20. 5, 10, 15, 20. 5 times 4 equals 20. I've now found all of my factor pairs, so I'm going to look for the greatest common factor. I'm going to go down just the 20 side and see if there's any numbers that are also a factor for 16 that are a factor for 20, starting with my largest one, 20. Nope, there's no 20 on the 16 side. I'm going to start with my second largest factor, 10. Is there a 10 over here? 1 times 16, 2 times 8, 4 times 4. There is no 10. I'm going to look now to see if there is a 5 on my 16 side. 1 times 16, 2 times 8, 4 times. There is no 5. I'm going to look to see if there is a 4. I see a 4 here and a 4 on 4 times 4 equals 16. So my greatest common factor of 16 and 20 is 4, because 4 is both a factor of 16 and 4 is a factor of 20. So I can reduce this fraction by 4 over 4. And because I've already written in my factor pairs, I already know what 16 divided by 4 equals. That equals 4. I rolled my 4s 4 times to get to 16. I also know what 20 divided by 4 equals, because 5 times 4 equals 20. So 20 divided by 4 equals 5. And this fraction, 16/20, reduces to 4/5. Once you enter in your answers on your Google form, click Next and shoot your shot on your independent practice. Peace.